In the previous video, we discussed about what a static variable really means, syntactically and also semantically. Let's see how we can apply it for automatically managing the account IDs. So this will be the solution. Let's see the same account class. What I'm highlighting in yellow will be the new additions. You can see we still got ID, we still got owner, and also we still got this particular constructor. I'm just omitting the get ID public accessor. It should still be there, right? So what we are adding over here is, number one, we are adding a private static integer over here. So static, don't worry too much about the private. It simply means this static variable should only be accessible by the account class, but not by any other class in the other context. Okay. Even if you got rid of private for this course, it will be okay. Okay. Let's say static simply means it's going to be global. It's going to be instance independence among the instances of account objects. And it's integer type, and also we call it global counter, initialized to be 1. So we don't really delay its initialization to any account objects like here. We don't do that, right? We initialize each static variable right away upon their declaration. And for the constructor over here, we'll simply say this .id over here, which is a string, it's an integer over here. It's an integer here. We simply assign to the current value for global counter, right? That's what we did. And then we're going to increment the global counter plus plus. So this is a really critical step over here when we say global counter plus plus. So that means the next account objects that's going to call the same constructor, they're going to get access to the shared copy for the global counter, meaning that the copy that has been incremented already. We'll see that when we visualize it. And then also initialize owner to be owner. Well, I just want to explain to you line by line, but we will trace it together with you just to make sure you got thorough understanding. So bear with me. And this will be some little test over here, but the most notable difference over here is if you compare with the previous one, you can see here when we try to call new account over here, we only pass the owner name as the arguments. You can see the parameter over here, we only got string owner, unlike before. If you recall before, in the previous version, we also need to pass manually the ID in order to make sure the IDs are unique. But now, with the help of the static variables, we don't need to do it anymore. We just need to do owner over here. And behind the scenes of any users for the account class, they can simply assume there will be some automatic mechanism, namely the static variable, which will make sure all the generated IDs will be unique. That's something we'll see. Okay, that's really noticeable difference you should really notice. And then we also make sure the IDs will be different, right? Let me just go over some points, and they will also review about the use of static variables, and then I'll visualize this example together with you. And then we are done for this example, and then move on to talk about some common errors for static variables. All right, so let's read it together. Each instance of a class, for example, you can see ACC1 and also ACC2, each one of them has a local copy of each attribute or instance variable. For example, they have their own copy for ID, they have their own copy for owner. However, they do not own the copy for global counter, which is static. Okay. For example, if you say changing ACC1.id does not affect ACC2.id, right? If you remember our visualization from before, if I modify this particular local copy for C1, it should not have any effects for C2 over here, right? It remains the same. All right, that's really what this point is about. Now, what about static? Oh, by the way, when we say attributes over here, we meant non-static variable. That's something we said already in the previous video. A static variable, for example, global counter over here, belongs to the class and is shared by all instances of that class. In this case, account. All instances of the class share a single copy of the static variable, right? That's really self-explanatory. And also changed to global counter either by ACC1 by ACC1 is also visible to ACC2. Similarly, if you try to change it using ACC2, it will also be visible to ACC1. What does that mean? For example, here, if you see, we say, let's say for the counter case, right? when you say C1 dot increment global, so here I'm using C1 as a context object. However, that one will modify the shared copy actually from 0 to 1, right? And also when I say C2 dot increment global, that will modify that from 1 to 2. But in both changes, when I try to get access to the counter by either C1 or C2, they will access just the same copy, right? It's just global, all right? Hopefully, you can appreciate at this point. If you got any trouble with these 2 points, feel free to ask me during the Q&A or maybe drop by my office hour. So that's really important for you to see. All right, just go over a few more points and then I will visualize the program. Static variable's global counter is not instance specific like an instance variable, right? Exactly. So you should really think about the nature for these 2 variables is very different from the nature of the static variable. How do you get access to a static variable? So you should really say no context objects needed, even though you can put it, but it will be a warning. So you can see here, I can say C1.g and C2.g. It would be okay, however, it would be a warning in the Eclipse, which I showed to you. So we are not really accessing static variable in a static way. So the proper way would be just say class name and then dot, the static variable. Right? However, and of course, on the other hand, if you want to get access to attributes, you must use some context objects for sure. And use of the class name suffices, right? You can say account.global counter, right? Because it's declared under the account class, so you can simply say account.global counter. Each time accounts constructor is called to create a new instance, the increment effect is visible to all existing objects of the account. So what I meant was, I'm going to visualize it. Every time a new account is being created, we must call the constructor for sure, right? And then under the constructor, we'll also say global counter plus plus. So every time we do this, it's going to have the consequential effects for the next instance to be created. We'll see that right away. All right. So these are the written points must make sure you actually understand. And then let's now visualize it to do some visual summary. Okay. So this is the code that we just went over on the slides. Let me now visualize it together with you. Okay. Again, we got non-static, and also we got static, right? In the constructor, we are trying to update the static variables over here. We're trying to, first of all, use it and also update it, okay? Let's now try to visualize what's happening over here. Let's be very careful about the order. To begin with, even before I try to execute the first line to create the first EECS1022, right? Even before that, I should have the global counter already initialized, which I showed to you in Eclipse already, right? So it's going to be the global counter, and I'm just going to say GC for short, GC. And the initial value will just be 1 over here. And then I'm going to execute the first line, for which I'm going to create EECS1022, and then the owner will just be Jim. Right? Let's now execute the constructor over here. But I know eventually I'm going to have EECS1022 actually pointing to this particular objects over here. So that will be the account. So that will be account. And what attributes do we have? We still have ID and also owner, right? So we got ID and also owner. Notice that I don't really put GC as part of the EECS1022. GC is independence for any instances. So we got ID and also we got owner. Okay. So we are now executing this particular constructor over here, and the owner will just be Jim in this case. Let's now this line, this.id. So now this will just be EECS1022, right? EECS1022. Okay, so now we are saying EECS1022.id is going to be the value for global counter. EECS1022.id, this part here is going to copy the value for the global counter GC, which is 1, right? So I'm going to put 1 over here. That'll be the first line. Hopefully you're following. And then I'm saying over here global counter plus plus. So that means I'm using this particular, in the context of this particular EECS1022, I'm trying to modify the GC because it's kind of shared by all the instances. So you may just update it from any of the instances. So after executing this line over here, so GC will go from 1 to 2 over here. So now 2 will be used instead by the second object account of type account to be created. We'll see that. All right, the next line over here. So EECS1022 the owner is going to be owner, which is Jin, right? So this one is easy. So that means it's going to point to some string and then Jin over here. All right, so far so good. And let's now try to create a second object over here. So we are trying to create EECS1022 and then calling the same constructor, and then it will be Jeremy, right? So that means the owner right now is going to be Jeremy. And then every occurrence of this is going to be EECS1022. So this will be EECS1022, right? EECS1022, that's a context object. Let's now see what's going to happen here. So we say that over here, this line, EECS1022.id is assigned to the global counter value. Oh, I haven't got EECS1022, have I? Let me just put it here. EECS1022 stores the address of the object that we are trying to create, right? And then it's also going to be of the same type, which is account. And then we also got ID and also the owner. So we got ID and also we got owner. Okay, let's now try to trace that code again. EECS1022.id is assigned to global counter. EECS1022.id is assigned to the global counter, right? Which will be 2. So that means we're going to put 2 over here, right? You can see this is the automatic mechanism I'm talking about. Since this global counter is global, so that means every time we update, increment it, it can be used by the next object to be created. For example, whatever you updates from 1 to 2 using EECS1022, the 2 can now be used by EECS1022, the next object to be created, right? Let's finish off the tracing quickly. And then we got the next one here, global counter plus plus, right? Global counter plus plus. So once we execute this line here, global counter is here, so go from 2 to 3. So that means if we got another EECS3 object to be created, the 3 value over here is going to be used, but we just don't show that, right? Finally, we're going to say EECS1022.owner is assigned to owner, which is Jeremy. So EECS1022.owner is assigned to Jeremy, right? So we're going to say this will store the address of the string Jeremy. All right, it's a very complete tracing. I hope that really helps. And then finally, let's now make sure we still satisfy the property for account ID. EECS1022 over here as a context object, and also EECS1022 over here as the context objects. And now if we want to get the ID, it will be 1 versus 2, right? So they are not equal to each other. So that's good. Really see the advantage of using the static variable here for the automatic managing for the account ID, right? It's really important because for the constructor, we don't have to explicitly pass the ID to the constructor anymore. We simply just use it. We simply just make use of the private, the hidden static variable to do the management. It's really important insight for you to see. All right. Now we are done with introducing the static variables and also use it in the context where we want some automatic management of some global variable. That's what we have seen. And I would like to talk about 2 common mistakes of using static variable. Let's now go over them.